Hello, good day. My name is Padilla John Michael, and this video is my video demonstration of Experiment 3 in ECEA105L. Now, Experiment 3 is entitled Programming with Time Delay Using 7-Segment Display. Now, the experiment that was given is divided into two parts. It has part 1 and part 2. So part 1 is titled Time Delay Using SSD. So again, just like how we used to do it, we already separated the codes that we will be using per part of the experiment so that we could be more organized in viewing the results. So here first we have to launch EDSIM, and after launching EDSIM we will now be encoding this code which we separated earlier, and we will be assembling it and running it to observe the results. So there. So after that, we will be assembling the program, and after assembling the program, we will be running it and look at the results. Okay, let us set this to 1 first. There, and as you can see here in our 7-segment display, it's displaying different numbers such as 1, 2, 3, and the next number that will be displayed should be 4. There, and then it just goes on, and after that we will be pausing the simulation and reset. Then after that we will be removing B. So if we assemble this, so as you can see it's still running. However, the output right here is quite different here in the 7-segment display, because B stands for binary, and since we removed it, the simulator is not recognizing the values that we are inputting in the code. So to bring it back to its original state, we must keep B, and after that we will be adding more numbers to the loop. So here we will be adding a new code. So here is our separated code for the next part. So to add numbers beyond 4, here, so we will be replacing the code. So now we will be assembling this, and now we will be pressing run. So as you can see, again it starts with 1. So for faster demonstrations, I think I will be increasing the update frequency to 100. So as you can see, the values are up to 9. So we were able to see um, the value 9. So let's bring it back to 1, and let's just use the step function. Actually, it takes more time if we use the step function, so let's just use the let's just run it with the update frequency of 1 so that we can see all the values. So first we have 1, next we have 2, three, 4, 5, 6, and 7, and then 8, and 9, and then it went back to 1. So as you can see, we were able to display 9 values, as mentioned in the procedures. Now, so that is for part 1. Now next we will be simulating part 2. So part 2 also has its own code. So for part 2 we have here our code right here. So first we will be again we will be assembling this, and then we will run it there. But before we run it, we should be pressing switches, some of the switches here. So let's say we assembled it and press let's press all the switches. Let's press the switch first. Okay, so to view the results, I increased the update frequency to 100. Let's reset, and again let's press all the switches. So as you can see, when we pressed all the switches, so all of the parts of the number are lit up, and Next is, let's see if we just press two of the switches as mentioned in the experiment. So if we assemble that, as you can see, only a selected portion is lit up. So that is for the second part of the experiment. So that would be all for my demonstration of experiment 3 in ECEA105L.